Hello all. Today we are going to learn about green chemistry. Green chemistry is the design of chemical products and processes that reduce or eliminate the use or generation of these hazardous substances. So it basically deals with it's a branch of chemistry that deals with the design of products, design of reactions in which we can reduce or eliminate the use of a hazardous substance. They utilize a set of principles so that we can reduce or eliminate the use or generation of these hazardous substances. So, in the design, in the manufacture, and the applications of these chemical products are carefully done with the help of some of the principles. It provides a number of benefits like it will reduce waste, you will be able to get safer products, reduce use of energy and resources, and improved competitiveness of chemical manufacturers and their customers. So, what are the focus of green chemistry? First focus is on the source reduction or the prevention of the chemical hazards. And the next one is the reuse or recycling of these chemicals. And then is the treat chemicals to render them less hazardous. So you can make them less hazardous and treat these chemicals accordingly. And then you can dispose these chemical properly. Disposal is somewhere where a lot of problems are happening. So disposal of these chemicals carefully being done. So that can also be that is also a focus on green chemistry. So now, as I was telling, there are some principles in which green chemistry is based on. So this is developed by Paul Anastas and John C. Warner, and they developed 12 principles of green chemistry. This is a very important principle. There are 12 principles according to which green chemistry is working on. The first principle is it is better to prevent waste than to treat or clean up waste after it is formed. So, whenever we are doing a reaction or whenever we are carrying out some industrial processes, it is always better to prevent the waste than treating it or cleaning it up after it is formed. Next one is synthetic methods should be designed to maximize the incorporation of all materials used in the process into final product. We should make sure that every material that we are using in this reaction are getting coming into the final product. Third one is wherever practical, synthetic methodology should be designed to use and generate substances that possess little or no toxicity to human health and environment. Should be able to design or you should be able to use uh, reactants which are less hazardous or less toxic to human health and environment. Fourth principle is chemical products should be designed to preserve efficacy of function while reducing toxicity. So we should be very careful when we are designing these chemical products. Fifth principle is the use of auxiliary substances. Like in many reactions, we use solvents. So we should be able to minimize the use of it or if it is unnecessary, we should be able to avoid it completely. So solvents can lead to considerable waste. So reduction of solvent is very important while doing green chemistry. Sixth principle. Energy requirements should be recognized for their environmental and economic impacts and should be minimized. So we should, when our reaction is carried out, energy requirements should be less. So you should conduct your experiments mostly in room temperature and pressure. Seventh point or seventh principle, a raw material or feedstock should be renewable. Whatever we are using as a feedstock or a raw material, that should be renewable so that it is more practicable. Eighth principle is reduce derivatives. So we know that there are derivatization process happening, that is protection, deprotection, or blocking groups. Sometimes we use in chemical reactions that should be avoided. That is unnecessary. So that should be avoided when you are studying green chemistry. Then the ninth principle, catalytic reagents are used in greater proportion than stoichiometric reagents. So as you know that catalyst can serve several roles while doing a reaction. So they can enhance the selectivity of the reaction, reduce the temperature, like that it will help. So catalytic reagents should be used than stoichiometric reagents so that we can avoid unnecessary or unwanted side reactions. 10th principle. Chemical products should be designed so that at the end of their function, they do not persist in the environment. So we should make sure that whatever we are doing, whatever reaction we are doing, it shouldn't persist in the environment once it is formed. And the 11th principle is analytical methodologies need to be further developed to allow for real-time in-process monitoring and control prior to the formation of hazardous substance. Analytical methodologies, we should adopt more of analytical methodologies in our reactions. And the 12th principle and the last principle is substances and the form of substance used in chemical process should be chosen to minimize potential for chemical accidents, including the releases, explosion, fires. So we should be able to be very careful when we are choosing the substances that we are using in the chemical process. We should avoid chemical accidents, fires, explosions, like that. So that is about green chemistry. I hope you all understood. Thank you.